Okay, so today's problem. In a three-phase power system, the line-to-line voltage is 480 volts, and the line current is 100 amps. The power factor of the load is 0.8 lagging. Calculate the apparent power, real power, and reactive power consumed by the load. So to start this, you really want to make sure that you know it's 480 line to line. That's really important. So what that means is that it's not between, say you have a delta Y system, so each whatever the 4a divided by square root of 3 is, 277 at each point technically. So 277 would be your voltage to ground. However, your voltage between the two is 480 volts. So it's important. So the formula for apparent power is apparent power S is equal to voltage line to line times the square root of 3 times your line current. And the square root of 3 comes from, if you draw real quick, a little waveform. It's not great, but a three-phase waveform. At any given point, the voltage is represented across the load as not 0, but square root of 3 times the voltage. So keep that in mind whenever you're doing solving for three-phase systems. It has to be the square root of 3 to get the apparent power. Um, so plug that in. S apparent power is equal to 480 times square root of 3 times 100 amps, which will give you 83,138.43 volt amperes. So apparent power is always in volt amperes. And then to solve for real power, you want to think of the power factor triangle. So you have your imaginary power Q, real power R, and then apparent power somewhere like here. So this vertical line is going to be Q, and your real power is going to be on the x-axis. So pretty simple. You remember power factor is 0.8 in this problem, so just go 83,138.43. And then to get this leg phase, just do 0.8. You don't have to use any cosines or anything, which will give you 66,510 watts, or 66.5 kilowatts. It might be in kilowatts depending on the problem. And then for the reactive power, you're going to want to do Q is equal to the square root of parent squared minus the real power squared, which, and you could probably also solve it using trigonometry, but this is a faster way usually because it's always going to be a right triangle. So whatever we got earlier, Q is equal to, and it kind of gets confusing if you want to use kilowatts or the regular watts, but I always prefer to keep my units unsimplified, so I'll use this. So 83,138 squared plus 66,510 squared, which will give you a reactive power. Sorry, this is subtraction. Whoops. Didn't mean to confuse y'all. It'll give you a 49,883.33. This is volts reactive vars. That is something to keep in mind, is that these two legs up here, this Q and R, will never be greater than the thing. So I had plus on my calculator. I actually added them. It was greater. That makes no sense. It will never be greater. Apparent power is always the highest. Thank you very much.